Here we will cover cyber attacks on Wi-Fi networks and over the web. Let's get started. There are so many different types of attacks. Sometimes it can be challenging to address them all within the context of our various lessons. So in this section, I've pulled together some attack types that haven't necessarily been covered in the earlier sections. Let's start with shoulder surfing. In computer security, shoulder surfing refers to using direct observation techniques such as looking over someone's shoulder to get information. It's commonly used to do things such as obtain passwords, PINs, security codes, and similar data. Simple ways to mitigate shoulder surfing risks are to use screen privacy guards and to dim the brightness of your monitor. Dumpster diving is looking for treasure in someone else's trash. In the world of information technology, dumpster diving is a technique that's used to retrieve information that could be used to carry out an attack on a computer network. Dumpster diving isn't limited to searching through the trash for various obvious treasures like access codes or passwords. Seemingly innocent information like a phone list or a calendar or even an organizational chart can be used to assist an attacker using social engineering techniques to gain access to the network. To prevent dumpster divers from learning anything valuable from your trash, experts recommend that your company establish a disposal policy where all paper, including printouts, is shredded in a cross-cut shredder before being recycled. All storage media is erased, and that all staff is educated about the danger of untracked trash. Tailgating is a technique often used by perpetrators when accessing restricted areas. Once a gate opens for a vehicle, the perpetrator slips in right behind them before the gate closes. Same holds true for door entry. Mitigating factors here include employee awareness and the presence of security guards. Impersonation comes in several forms. Physical impersonation might be dressing up as a janitor or a security guard. Digital impersonation could be posing as someone else online. Another type of attack is zero-day attack. Now, zero-day attacks are actually vulnerabilities initially to a previously undisclosed computer software bug that hackers can exploit to adversely affect computer programs, as well as their data and other computers on the network. Now, it's called a zero-day because once the flaw becomes known, the software's author has 0 days in which to plan and advise any mitigation against its exploitation. Attacks employing zero-day exploits are often attempted before or on the day that notice of the vulnerability is released to the public. Sometimes before the author is aware or has developed and made available corrected code. Zero-day attacks are a severe threat. Mitigating techniques here involve activity traps, which look for certain malicious behavior patterns. One example of man-in-the-middle attacks are active eavesdropping, in which case the attacker makes independent connections with the victims and relays messages between them. This makes them believe that they're actually talking directly to each other over a private connection, when in fact the entire conversation is controlled by the attacker. The attacker must be able to intercept all relevant messages passing between the two victims and inject new ones. This is straightforward in many circumstances. For example, an attacker within reception range of an unencrypted Wi-Fi wireless access point can insert himself as a man in the middle. SPIM is another type of attack vector, and it stands for messaging spam. Instead of spam, we call it SPIM because it's instant messaging. Now, SPIM is a type of spam targeted or targeting users of instant messaging services, SMS or private messages within websites. User education here is key in mitigating these types of threats. Now, you may have heard of a Christmas attack. Now, in a Christmas attack, this is where a Christmas tree packet is utilized, and it's a packet with every single option set for whatever protocol is in use. Now, this term derives from a fanciful image of each little option in bit and a header being represented by a different colored light bulb, all turned on as in the packet was lit up like a Christmas tree. Now, it can also be known as a kamikaze packet, nastygram, or lamp test segment. Christmas tree packets can be used as a method of divining the underlying nature of a TCP/IP stack by sending the packet and then awaiting and analyzing the responses. When used as part of scanning a system, the TCP header of a Christmas tree packet uses the SYN, FIN, URGE, and PSH flags. Many OSs implement compliance with RFC 791, and by observing how a host responds to an odd packet, such as a Christmas tree packet, assumptions can be made regarding the host's operating system. It can be a fingerprint of sorts. Versions of Windows, Cisco iOS, and IRIX display behaviors that differ from the RFC standard. A large number of Christmas tree packets can also be used to conduct a denial of service attack by exploiting the fact that Christmas tree packets require much more processing by routers and end hosts than the usual packets do. These packets can be easily detected by intrusion detection systems or more advanced firewalls. From a network security point of view, Christmas tree packets are always suspicious and indicate a high probability of network reconnaissance activities. Now, farming with a PH is a cyber attack intended to redirect a website's traffic to another website. So farming can be conducted by changing, let's say, the host file on a victim's computer, or by exploitation of a vulnerability in DNS server software. Now, DNS servers, of course, are computers responsible for resolving internet names into their real IPs. Compromised DNS servers are sometimes referred to as poisoned. Farming requires unprotected access to targeted computers, such as altering a customer's home computer rather than a corporate business server. The term farming is based on the words farming and then phishing. So phishing, of course, is a type of social engineering attack to obtain access credentials. Now, in recent years, both farming and phishing have both been used to gain information for online identity theft. Farming has become a major concern to businesses hosting e-commerce and online banking websites. Sophisticated measures known as anti-farming techniques are required to protect against this serious threat. Antivirus software and spyware removal software cannot protect against farming. Another type of attack is a privilege escalation. Now, privilege escalation is the act of exploiting a bug, design flaw, or configuration oversight in an OS or software application to gain elevated access to resources that are normally protected from an app or user. The result is that an application with more privileges than intended by the application developer or the system admin can perform unauthorized actions. Typo squatting is also called URL hijacking, and this is essentially a sting site or a fake URL, and it's a form of cyber squatting, and potentially and sometimes referred to as brandjacking, which relies on mistakes such as typographical errors made by internet users when inputting a website address into a browser. Should a user accidentally enter an incorrect website or address, they may be led to any URL, including an alternative website owned by a cyber squatter. Watering hole attacks are attacks strategies in which the victim is a particular group or an organization, and in this type of attack, the attacker guesses or observes which websites the group often uses and infects one or more of them with malware. An integer overflow occurs when a arithmetic operation attempts to create a numeric value that's far too large to be represented within the available storage space. For instance, taking the arithmetic mean of two numbers by adding them and dividing by 2, as done in many search algorithms, causes errors if the sum is too large to be represented and hence overflows. The most common result of an overflow is that the least significant representable bits of the result are stored. The result is said to be a wrap. Flash cookies are a new way of tracing your movement on the internet and storing lots of information about you. Their official term is local shared objects, and their primary purpose is not to track you, but to provide Flash applications with options to save data to the local system. This can be useful when you play games, as it's one way to save your progress. But since there's no distinction between good and bad uses, many companies have started to use Flash to save persistent information on the user system as an alternative to third-party HTTP cookies. Now, a major disadvantage of Flash cookies is that you can't locate them in your browser easily. They're not shown in the list of cookies which you can access if you open the cookie manager of your browser, nor do they appear in databases or other browser-specific storage locations. Normal HTTP cookies can't save more than 4 kilobytes of data, while Flash cookies can save up to 100 kilobytes by default. Now, if you want to try out how they work, you can do the following. Go to YouTube. You can increase or decrease your volume of a video and delete all your cookies afterwards. You'll notice that the volume is still at the same level when you close your browser. Now, this is done with these so-called local shared objects, better known as Flash cookies. The main question is, of course, how a computer can be checked for Flash cookies and how you can delete those cookies on your system to reduce exposure to tracking. Malicious add-ons are add-ons to the browser that can extend the functionality of a browser in some way. Some extensions are authored using web technologies such as HTML, JavaScript, and CSS. Browser extensions can change the user interface of the browser without directly affecting viewable content of a page, for example, by adding a toolbar. Now, sometimes attackers will inject malware into these add-ons to compromise user systems. Non-standard system attacks can include attacks on game systems, game consoles, in-vehicle systems, and even mainframes. So let's talk about game console attacks for a second. The Xbox One and PlayStation 4 were launched at the end of 2013. Not surprisingly, Kaspersky Lab reported that since there's been a rise in the number of hacking attacks on most video game platforms, including computers, and in average they're seeing about 34,000 attacks a day. Now, this is pretty alarming, but strangely most hackers are interested in Europe, with Spain and Poland being the first two choices for such attacks. Anyhow, Xbox One and PlayStation 4 have been the main target. The agenda here is to steal usernames and passwords to sell to others. Another type of non-standard data system are high-performance or HPC computing environments. These are clusters that encompass a collection of distributed resources to be protected. By definition, clusters are multiple closely coupled machines that are centrally administered. These machines share common resources such as network access, compute cycles, and storage. The challenge is to secure these internally distributed resources against unauthorized access while at the same time permitting easy access by legitimate users. In contrast, the resources found in typical enterprise-type environments are often very loosely coupled and exhibit minimal coherence of these types of resources. A high-performance cluster must provide mechanisms for resource management. The challenge here is to manage a cluster such that legitimate users can consume resources efficiently in an authorized way using an agreed-upon job prioritization system. This is distinguished from enterprise-type environments that usually do not need to manage resources between competing interests. When a user executes a job on a cluster, it's often difficult to differentiate legitimate versus illegitimate use unless there are obvious malicious process signatures. For example, legitimate HPC cluster users are potentially able to tamper with shared data or to excessively consume compute cycles to the extent of disrupting the service available to other cluster users. Clusters present a heterogeneous management environment. That is, a cluster may be composed of different hardware, software, and node configurations. Now, even in the case of clusters containing the same hardware and software node configurations, there's still usually a separation of cluster nodes by specialized function into head nodes, compute nodes, and storage nodes, and even management nodes. Now, the challenge is to coordinate security across different node platforms and different specialization function nodes. This is different from enterprise-type security in that cluster security management must be simultaneously platform independent and specialized for different functioning node types. Clusters have large-scale management requirements, and security is a process and not a product. As the sizes of clusters continue to increase, the task of maintaining and monitoring these high-performance clusters becomes an issue and a security issue. For example, one production cluster might consist of 1,500 nodes. At this scale, it's not practical to manage a cluster without leveraging the use of automation in conjunction with human interaction. Because of the heterogeneous management environment, tools to automate security management need to be aware of the similarities and differences present among cluster resources. In this way, cluster security is different from enterprise-level security because the tools that target enterprise-level security typically assume that every resource is subtly different. Clusters, considered as a coherent unit, exhibit characteristic behavior different from non-clustered machines. This is exhibited in network traffic patterns, number of bytes transferred, applications executed, and compute loads. The challenge is first to identify and later to understand these behaviors via profiling in order to provide appropriate protections. Finally, and perhaps most relevant to the idea, is that security for clusters is an evolving concept. Cluster resources exhibit dependent risk. In enterprise-level security, a single compromise on a machine may result in unauthorized access, destruction of data, and a platform for future attacks. However, a compromised machine in an enterprise can be quarantined to prevent cascading changes. In contrast, the security of the resources in a cluster environment is often dependent on the integrity of all nodes. A single compromised node in a cluster represents a dramatically increased risk to the rest of the cluster nodes due to the fact that many nodes share identical configurations. In this way, clusters are much more vulnerable to class break types of attacks. Now, experience also suggests that security failures in clusters are worse than enterprise-level failures due to the fact that cluster users tend to coordinate access across various geographically distributed resources. This coordination necessitates crossing security domains, and when one of these security domains is compromised, the attacker has a much easier job of compromising the other security domains. So, a whitelist is a type of attack that can be, or it can protect against attacks that are application specific. So we can, with application whitelists and blacklists, manage particular privileges and entities so that lists will either be accepted and approved or denied. Whitelisting is the reverse of blacklisting. And the practice of identifying identities that are denied, unrecognized, or ostracized. Application whitelisting is a computer administration practice used to prevent unauthorized programs from running. The purpose is primarily to protect computers and networks from harmful applications, and to a lesser extent, to prevent unnecessary demand for resources. In summary, understanding the varied types of attacks helps us as IT security practitioners to better plan countermeasures against them. Click on the webofsecurity.com link for the latest in cybersecurity news, test prep materials, including sample test questions, flashcards, ebooks, hands-on labs, study notes, and special offers for newly released cybersecurity training content.